Till now we discussed force as we discussed, and we know force has got four properties. What are they? Magnitude, direction, which come under the heading of vector, line of action, and point of application. We said there is no change in the effect of force as far as the point of application all along the line of action. That means we can certainly shift the point of application anywhere on the line of action of your force. For example, if you see it here, this is the force. You are represented by a vector which has got a magnitude, which has got a direction, and this is the line of action, ray. That means all along the line of action you can certainly shift the point of application. There is no change in the effect of this force. Now we are going to just discuss. So if you change the point of application not along the line of action, if you change it somewhere else on the body, what would be its effect? Now let us see. Now I have taken a body, a force F, which is acting at a point A. I don't want any change due to this change. I don't want but let us observe it. Rather, what would be the change due to the point of application shifting not along the line of action? For example, I want to shift it here, this point of application. Maintaining the same magnitude, by direction also we are maintaining both the direction and magnitude, and have shifted the force. Now, suppose if I shift the force, this is the one, due to this there is effect. Shifted. Previously, because of application of this force at this point, some effect is there. Now I have shifted it, maintaining the same direction, magnitude, but somewhere else, not along the line of action. In that case, there is an effect. I cannot say what would be the effect, but it is not going to be the same effect due to this force. For example, I don't want any change due to shifting of this point of application not along the line of action. In that case, how it is going to affect? What are the things come into picture due to shifting of this point of application of this force somewhere else? Let us see. Now how we are going to just explain it. Now I have shifted it because, as I said, I don't want any change in the effect. Now that means I am going to apply a principle called law of superposition. Law of superposition says, law of superposition, that means you are going to just subject the body with the same force, maintaining the same direction and magnitude, which are opposite in direction and which are collinear. Now you see here, I have applied the same force, two forces are applied, already your force is there, and if you imagine I have shifted the force in such a way, this is the shifting. What I said, there should not be any change in effect. That means I have taken two forces equal in magnitude, opposite direction, which are collinear. Due to this, what is the effect of this one? This is 0, because sigma f is equal to 0. This one I am going to call it as law of equilibrium of two forces. When these two forces are collinear, equal in magnitude, opposite in direction, that means the system is in, the net effect is 0. That's called law of equilibrium. Law of equilibrium of two forces. Due to this, effect is 0. Now you see, there is no effect, isn't it? Whatever the force is previously, whatever the effect it is showing, the same thing has been maintained. Now just let us put it in a different way. For example, if you see it here, there are two forces which are parallel, equal in magnitude, opposite in direction. As we discussed just a few minutes back, that constitute a couple. Now there is a couple here. If you see it here, what is the couple? If you take these two forces into consideration, according to the definition of a couple, there are two forces equal in magnitude, opposite in direction, parallel, constitute a couple. Isn't it? Due to this, now here what happens? A rotation comes into picture. So hence, whenever I am going to replace this one, these two forces by a couple. So hence, if you see it here, there is a rotation. rotation is about clockwise direction. So hence if you see it, two things have come into picture. One is you have shifted the point of application of your force somewhere else, not along the previous line of action. Yes, this is the one. What you have shifted here, apart from the, because of shifting, a couple comes into picture. Due to couple, a rotation takes place about this point. So hence whenever you shift a force not along the line of action, somewhere else, due to this shifting, the same effort, the same force is there by maintaining the direction and magnitude, but somewhere else. Apart from that, there is another one comes into picture, that is called, that is a couple due to the shifting. Right, sir?